Welcome to the Tesla Economist. Please hit the thumbs up and remember to subscribe. You can follow me on Twitter and talk to me on Patreon. So much has happened with batteries, EVs and Tesla and the world in general since Battery Day. I swear every time I watch some of Battery Day I pick up something new. It really is like an onion with layers of information. I thought we could go through Battery Day again and go over what was said and how best we can infer what it means with what we've learned since. Also, anything else you pick up, let me know in the comments below. Also, as we are hopefully about to soon finally get the actual specifications of what this tremendous breakthrough in battery tech has achieved, I thought it was a good time to remind us what we're about to finally see. Firstly, we're shown the number of terawatt hours that is required for batteries and cells to be manufactured every year to replace the current sales of vehicles. It's 10 terawatt hours. Tesla perhaps are around 70 gigawatt hours of battery supply in 2021, so Tesla's battery supply was around 0.7% of the total batteries required for all vehicles sold to be electric each year. And perhaps at Tesla's current rate, excluding 4680 batteries, so solely from their suppliers, they may be close to 1%. Remember, I'm only talking about Tesla, not all EV manufacturers combined. On Battery Day, Drew says that the average vehicle lasts 15 years, so we're talking about 150 terawatt hours to transition the global fleet to electric. Of course, the real question is how long will it take to reach 10 terawatt hours of batteries a year for vehicles? Elon has said at the Berlin opening, Tesla alone might reach about 1/4 of that in 10 years. We might hope that everyone else combined may also be able to reach the same level as Tesla alone by that stage, but we have no evidence of any plans for anyone else to reach that level yet. Then we see the same slide for energy, Elon saying that's a total of 20 to 25 terawatt hours per year, sustained for 15 to 25 years to transition the world to renewable energy. This is pretty much in line with what Elon was saying at Berlin, aiming for 300 terawatt hours total. We are referring to total here, not just Tesla. Hopefully there will be a lot of other companies helping by this stage, and billions, if not trillions, of dollars invested into achieving this. Remember, we're talking 10 to 20 years time to reach this scale, and then another 10 to 20 years of maintaining this scale. The technology will have hopefully improved drastically by then in all sorts of ways, especially given we're going to see about 1,000 times more invested into achieving this. And it won't stop there either. Maybe the Texas Institute of Technology and Science will come into fruition, but even if it doesn't, there'll be a lot more people studying about battery engineering and manufacturing and everything related to this massive mission. There'll be more labour available to facilitate the transition faster, along with more minds opening up and expanding. In other words, the bandwidth to expansion will increase. One major problem is that battery factories do not produce enough output and require an incredibly large footprint relative to output, making it not a sustainable path with the previous processes of producing battery cells. If Giga Nevada was ever complete, it might have eventually achieved 150 gigawatt hours and would have been the largest factory in the world by footprint at the time. In order to achieve that, that's enough for about 2 million vehicles a year, or a drop in the ocean. The math comes to 35 Giga Nevada sized battery factories to reach the 20 terawatt hour a year figure, with a cost of $2 trillion. And this is the major problem that Tesla were trying to navigate around, a way of producing a lot more cells in a smaller factory. However, all legacy autos and competition are still producing cells in this way. In fact, most of them aren't even there yet. They haven't even finished building their Giga Nevada equivalent factories yet. Yeah, they're really far behind. Yet some people do like showing me how much Ford is investing in battery factories, like it means something. Well, this is the reason it doesn't mean anything, and why dollar figures aren't the correct figures to be looking at when it comes to battery factories. Elon talks about how it's not even about the money anyway. That's not the scarce resource. The world is awash with money. The scarce resource, Elon says, is effort. There is only so much effort to go around in making these facilities, and you have to allocate the effort as efficient as possible. There are only so many engineers in the world, and it's all hands on deck right now. And of course, for there to be more EVs, well, they have to be at a price that people can actually afford. And Elon refers to more affordable cells by $1 per kilowatt hour, and how that will need to reduce, as it is the most determining factor in the cost of a vehicle. But the problem is the curve for the cost reduction is not reducing fast enough, and is actually flattening out, meaning that EVs will not become affordable for the masses on the current trajectory. And that is why we have Battery Day, designing a battery from the ground up using first principles thinking. So we go on to working out how Tesla are able to reduce the cost per kilowatt hour, which was the main focus of Battery Day, but not necessarily the most important aspect. But the plan was to halve the cost per kilowatt hour of batteries. And this cost saving would be starting from where they were at the time with the 2170 cell, which is estimated to be around $150 per kilowatt hour. Therefore, we might expect the 4680 cost to get down to around $75 per kilowatt hour, excluding inflation and everything else we're going through. Now, they're only talking about kilowatt hour here, not talking about halving the cost of the battery. In other words, if they're able to make vehicles with a lot of weight saving, then they'll require fewer kilowatt hours of cells, which would save the cost of the actual battery further again. Now, Tesla start going into each individual aspect on how they're able to cut the cost, beginning with the cell design and size itself, or form factor. They show us an example of a cell and use the 2170 version as an example, which would also further imply that all these comparisons are based from the 2170 cell. We're shown a graph as the optimal diameters for range and cost, and you can see the 46mm diameter is kind of the sweet spot, hence why it was chosen. There are two factors here, range and cost. Therefore, cells for energy storage would not need to factor in range, and could have form factor designed more suited to their application, which is why we expect Tesla to make a new form factor for their LFP energy storage cells. However, when you have a wider diameter cell, you do run into other issues, one being charging times take longer. However, Tesla are using tabless design, and one of the benefits of that, despite the larger cell, is it doesn't take much longer to charge. But it would also appear that 4680 cells will likely have a slightly longer charge time, but I think this trade-off is negligible compared to the other benefits the 46mm diameter brings. There are lots of other advantages of tabless too. Simpler manufacturing, the line doesn't need to stop and start for each tab, and thus can be a continuous assembly line. Removing tabs is a major breakthrough for production, fewer parts, and 5 times reduction in electrical path, and that's a big deal. It means the distance the electron has to travel is less, a shorter pathway in a larger cell, meaning despite it being a bigger cell, it has more power to weight ratio. This is a really big deal and will allow for easier thermal management. Tabless is a major breakthrough. It allows a lot more flexibility in cell design to allow for optimal performance. Then the all-important form factor that offers 5 times more energy and 6 times more power and 16% more range. Now remember, although it has a lot more energy and power, it also has 5.5 times more volume than the 2170, so its volumetric density is lower than the 2170, but volumetric power density is slightly higher. But the cells are longer, which means they actually only take up 4.5 times as much area, so the area density is still higher than the 2170. And because these cells are much larger, you can fit in a lot more of the jelly roll inside the can, relative to the surface area of the can, i.e. you get more jelly roll for every gram of casing in a 4680 cell. Thus, using less casing reduces weight and results in a 16% range increase. Now, a lot of people say that these battery day advances will take years until they see the full effect, and they are likely right. They will certainly continue to improve though, but the weight saving is felt instantly in these cells. They tell us that these are already in the pilot 10 gigawatt hour a year facility in Kato Rd, but Elon does say it will take a year to reach capacity. Then Elon says the actual production plants will reach in the order of 200 gigawatt hours a year, or maybe more over time. And I've been estimating 250 gigawatt hours, so that aligns, but it could take a year to ramp up to that. And if Tesla are hitting 200 gigawatt hours a year by the end of next year, just in Texas, then that's enough vehicles for about 3 million Model Y long ranges a year. Tesla could be at a battery production rate sometime next year for enough 4680 cells for 3 million Model Ys just from Texas. Those cells are made for vehicles from that factory, which would therefore imply the factory should have a capacity of 3 million vehicles a year. Then we move on to the cell factory design, which I think a lot of people, likely not any regular TV viewers, but other people, don't seem to understand. Tesla are trying to scale big, to the extreme. Therefore, the design of the factory is paramount in getting it to produce as fast as possible. Tesla have taken inspiration from other factory designs like printing and bottling in order to work out how they can produce these batteries as fast as possible. Obviously, the tabless design was a great addition to that too, as we already mentioned. So Tesla are doing everything they can think of to be able to produce batteries so much faster. This is the reason no one can catch up to Tesla. Yes, Tesla are ahead in a lot of ways, but this is the main one. The speed at which they can produce batteries. Batteries are the limiting factor in growing an EV business. Whoever can make them the fastest can grow the fastest. It's really that simple. Well, not entirely that simple, as they will need to also do so at a profit too, or else they've just increased the rate at which they go bankrupt that much faster. Of course, it's one thing making a new factory that can make cells at a really rapid rate. The other thing is actually making the factory itself. If the factory is enormous and takes years to build and costs a fortune, then that's also going to create issues in ramping. I mean, it's not just about how fast you can produce the cells, but also how fast you can produce, well, the machine that makes the machine. Again, this is just another reason why no one else is able to catch up to Tesla, for lack of a better word, or perhaps why the rest of the entire industry combined can still not catch up to Tesla. If anyone comments about Chinese cars taking over, then you haven't done your research. You've just listened to other people's opinions, who probably aren't economists. Anyway, this is where the electrode process comes into it, the current process being wet, and that if you can go from a dry mix to coat, it would save so many steps and processes in producing cells, and as we know, this was a major step change for cell processing. But if you can achieve the dry battery electrode process, it would reduce the footprint by 10 times and use 10 times less power. This is another huge breakthrough, and they talk about just how truly difficult this process is, implying it's going to be so much harder for anyone else, or maybe near impossible. If any other auto manufacturer wants to start producing millions of EVs a year, then this is an essential step. We then move on to the actual assembly line, and the key for this is to accomplish processes whilst in continuous motion. Think of it like a highway without traffic lights or stop signs. This comes to an output of 20 gigawatt hours per production line, or 7 times the line output when compared to Giga Nevada. The batteries will come off the line 7 times faster. And if Giga Nevada is about 35 gigawatt hours a year, then this comes to 250 gigawatt hours a year. Elon and Drew go in deeper about just how important manufacturing is and how Tesla will become the best manufacturing company on the planet. And this is something we continually hear from Elon, often citing prototypes are easy, volume production is hard. They have to become exceptional at manufacturing, as there are so many batteries and vehicles to make. It would have taken centuries to transition the world to renewable energy with the old processes. Formation is another major step in cell production. Formation is when you charge and discharge cells to verify the quality. Formation is 25% of the factory investment, and Tesla have new formation processes that reduce costs 86%, whilst also reducing the footprint a further 75%. With all these improved efficiencies, we end up equating to a 10 times smaller footprint of a factory per gigawatt hour generated, and the factory itself costs 75% less per gigawatt hour. And they say there is definitely room to improve beyond that further. Elon talks about how confident they are that they can hit 3 terawatt hours before the end of 2030. However, since then, this may not be quite as likely, but possibly within about 10 years' time from now. Admittedly, Tesla are behind on their progress of the 4680 battery. However, we have recently seen a massive step, with them actually opening the factory in Texas, which is the most important thing to keep an eye on as an investor. Okay, so far they've explained that this is now a much more simple, lower cost and faster way to make cell factories through all these new processes. But now we get to the actual chemistry of the cell, and how they're able to improve the energy density at the actual cell level, or more the jelly roll itself, the anode and cathode. Now the chemistry is what we might see continually improve over time with these batteries, and this full effect may not be felt instantly, but surely we expect a reasonable improvement from the start. The biggest chemistry improvement is in the anode. The anode stores the lithium where the battery is being charged. The anode is mainly graphite, but silicon can store 9 times as much lithium than graphite. The more lithium you can store, the greater energy density you can reach. Then you'd be forgiven for asking, why not make the anode out of silicon then? Well, although it can store more lithium, it will expand in size by as much as 4 times. The expansion creates too much stress and the particles start cracking. Essentially, it affects battery degradation. Instead, Tesla start from the raw silicon and design it around expansion. The anode previously had silicon in it too, but through this process, Tesla can add more along with the graphite and reduce the cost of the anode to $1.20 per kilowatt hour, not adjusted for inflation, etc., whilst also increasing the range by 20%. Now, what does the range increase actually mean? Does it mean that the cells will have 20% more kilowatt hours with this new chemistry? Well, no. 20% more kilowatt hours doesn't equal 20% more range, everything else being equal. For example, the old Model 3 standard range with 2170 was only about 50 kilowatt hours, with about 260 miles of range, and then the additional 30 kilowatt hours, or 60% more battery, for the long range, only added about 100 miles more. 60% more cells equal 40% more range. However, those additional cells also weighed a lot more. What's so special here is that we're getting more kilowatt hours from what is likely about the same weight. Due to this enhanced chemistry, it is a virtuous circle, as it actually means you need fewer cells for the same range, which reduces weight again even further, resulting in even fewer cells required again. So what kind of energy density improvement might we have seen here? If that is the case, to get 20% more range, well, it probably is about 20 to 25% improved energy density. The next chemistry change is in the cathode. The cathode is what stores the ions when the battery is discharging. They compare 3 different cathodes, iron, nickel and cobalt, for price and energy density. Nickel has the highest energy density, whereas iron is the lowest cost. These costs are not per ton, remember, but per watt hour, and not their actual density as an element. Nickel is actually more dense than iron, but can store more ions. Current cathodes for lithium-ion that use nickel are mixed with manganese, cobalt or aluminium. Tesla's 4680 has a much higher concentration of nickel, which is the highest energy density, and still a low enough cost for feasibility. Not only that, they also managed to remove cobalt, which is expensive, and often sourced from the Congo, which is not economically stable nor particularly ethical. This is another major breakthrough: high energy-dense lithium-ion batteries without using cobalt. It is such an advantage, whereas everyone else is still at the mercy of unpredictable cobalt. That's right, all the new legacy factories being built will be making batteries with cobalt in their cathodes. Obviously, LFP doesn't use cobalt either. Therefore, the chemistry improvements add an additional 24% range, which could likely be about 30% increased energy density. Then another 16% increase from the 4680 cell form factor itself. We have 40% more range, which could be about 50% improvement in gravimetric energy density. If the 2170 is 260 watt-hours per kilogram, the 4680 could be 390 watt-hours per kilogram, with a path to break 400. FYI, 400 is the magical number to make electric air travel feasible. However, with air travel, you could justify battery costs at probably 20 times the price, and thus improve it even further. This then brings us onto Tesla's diversified cathode approach. The fact that different cathode types are more suited to different applications, particularly when you're dealing with scarce resources. These high nickel cathodes will eventually be more for the semi-truck, roadster and cybertruck, as they need the extra energy density, and the additional costs can be passed onto the vehicles. Then we have nickel and manganese cathode. Now this could possibly be what they're using now in Texas, as these battery packs are for Model Ys. However, Elon has said since that they are making the high nickel cathodes. Elon has also suggested that they may be able to make high manganese cathodes later too. That would be an incredible leap forward. Manganese energy density isn't far off nickel, but it's a lot more abundant. Then we get to the iron cathode, aka LFP, which is suggested on battery day it will be standard range, energy storage and the compact. Elon has said about 80% of batteries that Tesla use will end up being LFP. If half of all batteries are for energy storage, then that would leave 60% of vehicles still using LFP. That is major, and we expect Tesla to make their own LFP cell. In fact, it is in this slide where the entire theory of Tesla will make a 4680 LFP cell is derived, and I encouraged it. About a year ago, I started making videos on how incredible Tesla's 4680 LFP will be, until Elon said outright there will be no 4680 LFP. They will use a different form factor, and I hope and expect there to be a battery day part 2. I expect 2 LFP form factors, one designed around energy storage, another for low-cost vehicles. Tesla want to scale to the extreme, but they can only scale as far as there are physically enough elements to reach it. If there isn't enough nickel on the planet to achieve this mission, then they have to find alternatives. Luckily, there is enough iron. Then we're shown how inefficient the process is to make the cathode, and Tesla have found a much better way. Better for the environment, less cost and faster time, and I think the cathode is now all processed at the new factory in Texas. As Elon goes on to say, cathode production would be part of Tesla's cell production. Producing the cathode locally reduces miles travelled by 80% too. Of course, we then move on to lithium, and are told about their new sulfate-free process of extracting lithium from the ground, resulting in a 33% reduction in lithium cost. Now, despite all these crazy lithium prices and lithium shortage scares, there is a lot of lithium on Earth. There just aren't possibly enough mines. Elon was thinking about this a long time ago. I would say they have their lithium supplies sorted for years and years, but the expansion they are aiming for isn't going to be at the same rate of expansion the mines are likely to reach. Therefore, it becomes a limiting factor. So what are Tesla going to do, or have to do? As Elon says in a tweet, they have to get into lithium mining. Whatever it takes for this mission, there is no giving up, no task too big, it just needs to be done. Tesla is not messing around. At the end of the day, it's minerals out of the ground into a factory and finished product out. There's always a way, especially with the level of resources and vertical integration this company has. In Battery Day, of course, we all recall Elon telling us just how abundant lithium is everywhere, even saying there is enough lithium just in Nevada to convert all the US fleet to electric. However, the mines might just not be opening up fast enough. It's possible that the government may want to help facilitate lithium mining too. We are not short on lithium, just need more mines, as we are scaling to the extreme. And of course, we left our favourite to the last, the structural battery pack, as it's mostly known. But as this really is such a profound design, let's go over it in detail, starting with the fact that you no longer need the structure in the battery pack. Significant weight saving instantly, as much as 10% reduction in mass, if you include the castings too. That's 10% of the entire vehicle. And given this example was based on a Model Y, and a Model Y weighs 4,500 pounds, then that is over 400 pounds of weight saving. That is huge. It is the cells themselves that are being used as the structure. The cells are glued to the top and bottom sheet. The filler for the batteries is also structural adhesive in a honeycomb structure, and obviously flame retardant too. A honeycomb sandwich with 2 face sheets. This ends up making the structure incredibly stiff. This would in turn further improve handling. Anyway, as there is less structure in the pack, there is more area to place more cells. This is what I recently discussed about CATL's new battery pack, and them saying they can place more of their prismatic cells into the pack compared to the 4680 cells. But Tesla can place more 4680 cells in their pack than CATL can place prismatic in theirs. Do you see? Tesla have freed up more space in their battery pack due to removing the structure, as it takes up less room. However, it goes even further than that. Due to the improved energy density and weight savings, then Tesla need fewer cells in the first place, which means these cells can instead be placed more in the center of the vehicle compared to the edge. Why is that a big deal? Well, safety for starters. It reduces the possibility that these cells will be impacted in a crash. But of course, it's Tesla, the gift that keeps giving. Having these batteries closer to the center also reduces the polar motion of inertia. A classic example of polar motion of inertia is an ice skater spinning around, and how when they pull their limbs in towards their body, their velocity increases significantly. Now, although this won't increase the velocity of the vehicle, it will make for much better weight distribution when the car corners. It will just feel better and easier to drive. Wow, I really want to drive a 4680 vehicle. The front and rear castings and structural battery pack end up reducing the floor space of the car factory by 35% and a 55% reduction in gigawatt hours. All of this in total ends up bringing the reduction in dollars to kilowatt hours by 56%. I believe that it was currently costing Tesla around $150 per kilowatt hour for 2170 batteries. That would thus take the cost down to $66, but that might even be at the pack level. Although there are a lot of people in the community who think this may even come down to under $60 per kilowatt hour. But of course, before inflation and supply chain issues, either way, a massive drop in cost. Then when we put all of this together, we have a range increase of 54%. Now, as amazing as that all sounds, we don't really know what we're comparing here. 54% more range compared to what? Well, obviously a Model Y with 2170 batteries. Okay, sure, but are we talking about the kilowatt hours of the 2170, the area of space taken in the battery pack of the 2170, or the mass of the 2170? My guess would be the area, and I'll tell you why, as the chemistry has also changed and improved the density, so that every squared foot or meter is able to contain more kilowatt hours due to this improved energy density. However, it does also mean that less kilowatt hours are required for the same range. This seems to be something people struggle to get their heads around. But yes, when you reduce the weight of an EV, you get a longer range, which would also mean you could reduce the kilowatt hours to get the same range it previously had. Therefore, fewer kilowatt hours will be required. To what extent we don't know, and if this new standard range, well, to be honest, this new standard range spec doesn't actually fit in with that math. The new Austin Model Y has a range of 279 miles, which is 50 miles less than the long range, but the battery pack is only an additional 13 kilowatt hours in the long range. This doesn't stack up. And a lot of people have a lot of theories around what is really happening, like software limitations, empty cells, or all sorts of ideas, because the numbers aren't adding up. Anyway, surely that will be revealed soon. Then, of course, we have the 56% reduction in dollars per kilowatt hour and 69% cost reduction in gigawatt hours. This then puts the total cost reduction of cells on a new trajectory, which will take a year to 18 months to realize these advantages. And Battery Day was about 18 months ago from the time of this video. And we're about to see some of these advantages in the new factory. Granted, we did see the rear casting earlier, but to fully realize the advantages, it will be about 3 years or thereabouts. So likely sometime in 2023. But we know that the Texas factory already has the structural battery pack and 4680 cells. So the rest of the progress will likely just be in the chemistry, which will evolve over time. In the meantime, we do get to instantly realize all the benefits of structural pack, castings and 4680 batteries, which still make a massive difference. Not to mention likely some chemistry improvements too. Elon then explains how Tesla's progress will speed up as it needs to scale up to the extreme. This is Elon talking about planning his massive scale up back then, but they didn't have any cell design that was feasible to scale up then. This is what they've been working on for the last 2 years or more, probably a lot longer actually, to create a battery that is actually scalable to the masses. Or else they could have just expanded the 2170 cell facilities. There's a reason that growth has diminished. Alright, and then comes the $25,000 vehicle. Elon is confident that in the long term, Tesla can design and manufacture a $25,000 electric vehicle. So that was a long-term plan, and perhaps will be released in the second half of the decade sometime. There was also no mention of it being the robotaxi, or even a compact, just a $25,000 electric vehicle. Therefore, I think the $25,000 vehicle is not the same vehicle that Elon is talking about as this dedicated robotaxi. Wow, how cool is all of that? And what's even cooler is this is what the new Texas factory represents. That is what they have achieved there. In fact, that factory is so impressive, it's only a small part of it. We will soon finally get the specifications of these batteries and vehicles, and the electric vehicle industry will never again be the same. Thanks for listening. Please hit the thumbs up and subscribe. You can follow me on Twitter and talk to me on Patreon.